All right. Morning, everyone. I'm Greg Pauloski. I'm a PhD student here in Globus Labs. I'm going to talk about ProxyStore today, which you might have heard mentioned in a few of the presentations yesterday. A lot to get through, so let's go quickly. I first want to start with kind of a reminder on what the motivation of ProxyStore originally was when I presented it last year at ParcelFest. It kind of came about from two kind of challenges when you're using Globus Compute in your workflow. The first is when you're kind of unnecessarily moving data into the Globus Compute cloud service when your client and your executor are both within the same network. Like maybe in this case, you want to use a high-speed InfiniBand network that exists between where your client and your workers are running. So how can we avoid cloud transfer costs but keep the benefits that cloud services provide to you? And the second is, when your client and your endpoint are in different networks, can we do peer-to-peer transfer directly between the sites, kind of circumventing some of the limitations of cloud transfer, such as the 5 megabyte payload limit that Globus Compute adds? And more generally, these issues kind of come about of this notion that and a lot of times we tightly couple the flow of control and the flow of data in our workflows, but really they need to be treated separately. And when you treat them the same, you're going to have to make compromises somewhere. And I think we tend to make compromises on the data side, at least in kind of Parcel and Globus Compute. So hopefully with some elegant new programming paradigm, we can kind of get the best of both worlds. And that's what ProxyStore aims to do. So ProxyStore gives you elegant pass by reference in distributed Python applications. It gives your program the illusion that data is flowing through one path, while we actually do the heavy lifting of data communication via some more optimal method. And so this gives us a mechanism for transparently decoupling the control flow from the data flow in our application. And we support a whole bunch of different kinds of object storage and communication methods, which I'll talk about in a moment. So what's a proxy object? A proxy object transparently wraps some target object, and it acts like a wide area reference to that object. It's initialized with the factory function, which is just any callable that when called produces the target object. And so that factory has all the metadata necessary to know where the target object lives and how to go back and retrieve it correctly, no matter where that factory function is being executed. And then the proxy gives us just-in-time resolution of the object. So the proxy will wait to call the factory function until the proxy is first used for something. So I'll give you an example here of how you might use ProxyStore. The main interface is this store class, which is initialized with a connector. The connector is kind of the low-level interface to whatever object storage and communication method you're using. Here is an example. I'm using the Redis connector, which is going to interface with a Redis server here running locally. And if I have some, my object, which is an instance of my data, and I want to create a proxy of it, you can call store.proxy on that object, and you get back a proxy. And then if I have some function that's executing kind of anywhere that takes as input my data, we can pass a proxy of my data in place of my data to that function. And even if my function inspects that data to make sure that it's the correct type and it gets a proxy, it's still going to work exactly as you expect. But the resolve of the data is going to be deferred until my function first actually uses that proxy. So why do we like this lazy resolution? A whole bunch of reasons. Performance, if you think about why you might want to use pass by reference in like a C-like application, there's a parallel here. You avoid duplicate kind of copying of your data across Python processes when those intermediate processes never actually need the data for a computation. You can do things like asynchronously resolve them. If your task fails fast, you avoid unnecessary communication of unused objects. You can avoid writing shims or wrapper functions. How many of you have a function here that's like, if my input is instance path loaded from disk, if it's some other type of object reference loaded from somewhere else. You get to avoid all of that boilerplates. Partial resolution of large objects with nested proxies, and then also access control. So make sure that a proxy is only resolved where it's permitted. So if you don't want to send your data to the Globus Compute Cloud Service, you can send a proxy in its place and still get all the benefits of Globus Compute. Here's the life cycle of a proxy. So if a producer wants to send an object to a consumer, the producer puts the object into the store, and it gets back from that a proxy. And what the store is going to do is going to serialize that object, put it in the connector. The connector manages the actual storage and communication of that. And then the store returns to you a proxy initialized with a factory function that has all the metadata necessary about how to get that object back. And then the producer can send the proxy to a consumer, and the consumer gets this proxy, but it just thinks it's the normal object type that it expected. So the consumer is kind of totally unaware of what's going on behind the scenes here. And when the consumer first uses that proxy, that's going to trigger this resolution process totally behind the scenes. The proxy will create a store and a connector interface if it needs to, and it'll go and retrieve the target object, return it to the proxy, and the proxy just behaves like that normal object. So what's changed since I talked about ProxyStore last year? A whole bunch. We've had many new versions of ProxyStore, and we kind of have a stable API now for this. New architecture, which is this store and connector interface that I mentioned. We support a whole bunch of new data transfer methods, peer-to-peer transfer between different sites, RDMA, Deos if you're using Sunspot or Aurora at ALCF, and it's really easy to bring your own connector if you have some new communication method you want to use. We also have an SC23 paper, so if you're at SC, I'll be presenting this in more detail, I think Wednesday afternoon there. So how do you use ProxyStore and Parcel? Well, there's a whole bunch of ways, but I want to shout out some work that Ben has been doing on serialization plugins in Parcel. So actually out of the box now, Parcel has a ProxyStore serializer, which you can use to replace kind of the default serialization that Parcel gives you. And what this will do is it will take your task inputs and outputs, it will put those into ProxyStore and then serialize just the lightweight proxy along with your task. And this can greatly reduce kind of overheads, data transfer in your Parcel applications. And then what about Globus Compute? Well, there's a whole bunch of different ways to use it with Globus Compute, but I'll shout out this one method, which is kind of how we can avoid cloud transfer costs in Globus Compute using this ProxyStore endpoint model. So endpoints kind of have a one-to-one mapping between your Globus Compute clients and endpoints. And what they do is enable peer-to-peer transfer between different sites. And this is all without needing to open ports. So you don't need any admin privileges to do this, which is really kind of the neat thing about this. I'm not going to go too much into the code here, but I'll reference these two guides here on our docs. The first is kind of why you would want to use ProxyStore with Globus Compute and how you might do that. And then the second one is a deep dive into actually how the ProxyStore endpoints work. If you're used to using Globus Compute, you'll see the interface and setting it up is pretty similar. So with that, I'm happy to take any questions. If you want to learn more, links are there, our SC papers on our website. Feel free to bug me with issues and stuff on GitHub if you're using this yourself.
Any questions?
Andre.
How well does ProxyStore works increasing the users? I mean, is there like a bottleneck? What happens? Does it crash? Do like scaling, does it replicate at one time?
So that all kind of comes down to what connector you're using at the end of the day. And so we support, I showed that table, a whole bunch of different connectors that all have kind of different performance implications. So for instance, if you're using like the Globus transfer connector, that's going to totally depend on the Globus transfer server, like at the site that you're using, right? But if you're using maybe something like ZMQ, that's kind of set up on a per user ad hoc basis. So you're kind of just limited by your network performance. So you can kind of pick the data transfer methods depending on what suits your purposes best. We also have an abstraction where you can combine multiple connectors with a policy-based approach. So if you know like certain objects of certain sizes you want to transfer one way, and then maybe for different sites you want to transfer using a different method, you can combine them all together in kind of interesting ways.
You need to just delegate this problem to...
Yeah, because I mean, I think there's no one-size-fits-all solution here, right? I mean, how many of you have used like 1,000 different data storage and communication methods, in your life? ProxyStore kind of gives you this neat way of write your program independent of what transfer method you're using, and then you can use ProxyStore to kind of switch out whatever you're using at any given time.
Thank you.
Yeah.
I mean, I guess I'm kind of slightly curious about that you're making a lot of this transparent to the consumer.
Mm-hmm.
I guess I'm wondering how much of this could be also transparent to the developer.
Yeah.
Because there's a lot of kind of hand stuff now that I could imagine maybe automating, maybe using machine learning to figure out at some point.
Yeah, I mean, one thing we're kind of interested in is can we pick the transfer method on behalf of the user? Yeah. That's kind of something that's on our to-do list of like, this is something we want to learn, but we haven't gotten to that point yet. I think that's kind of the next cool thing. One of my next big projects is can we treat proxies like futures, like pass a proxy before the data to it exist, and then have some process living somewhere else kind of asynchronously set the result on that proxy. And that enables you to kind of do some cool chaining of dependencies between tasks. And then maybe we can do some intelligent movement of the data behind the scenes once we know where like the future proxy ends up.
All right.